Okay, what we're going to do today, we are going to work on prime factorization, okay? And it's probably something that you guys have already kind of got a start on. You did a little bit of it last year, but we're going to work it a little bit further today, add a couple new things that you probably haven't done before. Now, when I tell you to find the prime factorization of something, basically what I'm asking you to do is to break it apart into the smallest pieces that you can, all right? So, if I had this Rubik's Cube right here, and I asked you to find the prime factorization of it, basically what you do, you break it all apart until you had, 27 different squares, okay? 27 little different squares there, all right? So, prime factorization means just break it down as small as you can. Now, before we start it, I need to show you some numbers, okay? The first thing you have to know is whether a number is prime or composite. I think this is something we already know. A prime number is a number. Who's doing that? Thank you. A prime number is a number that can only be divided by 1 and itself. Okay? And you guys had that before? You guys have done that before, right? A prime number can only be divided by 1 and itself. Now, there are an infinite number of prime numbers. An infinite number. That means we could not list them all. They keep going and going and going forever. But there are 5 that I want you to know for the time moving forward. All right? Those numbers are 2, 3, 5, 7, and 11. Memorize these. These are key prime numbers. I want you to write them down at the top of your whiteboard. Write them small because they're going to stay there all day. Okay? 2, 3, 5, 7, 11. A couple of things I want you to notice. First thing that I want you to notice is that 1 is not a prime number. 1 is not a prime number. Yep. Now, also notice, so there are 2 things that I want you to notice. Number 1 is that 1 is not a prime number. Number 2 is that 2 is a prime number. Okay? 1 is not a prime number. 2 is a prime number. Yes, sir? 2 is the only even prime number. That is correct. Okay? So 1 is not prime. 2 is. 2, 3, 5, 7, 11. Those are going to be our key primes. Now, first thing that we have to do is determine whether a number is prime or composite. A prime number, like we said, can only be divided by 1 in itself. And a composite number, there are different numbers that you can divide it by. Okay? Like you can split that up. Like that Rubik's Cube that you can split up into a smaller piece. 45 is a composite number because we can split it up into smaller pieces. If you have your calculators, you can use them. Alright? If you can do it in your head, you can do it in your head. But just looking at 45, I know I can divide it by 3. Okay? I can divide it by 5, I can divide it by 9, I can divide it by 15. There's lots of numbers I can divide it by. But what were my key primes again? 2, 3, 5, 7, and 11. 2, 3, 5, 7, and 11. And so what I'm going to do is I'm just going to look at this number and I'm going to ask myself, can I divide it by 2? And I can't. Can I divide it by 3? Yep, I sure can. So if I can divide it by something, 3 and 15, this is composite. Alright? Next one, 17. Now maybe you already know this, but play along with me. Can I divide it by 2, 3, 5, 7, 11? So we're going to call it prime.
Well, you could, but it would be not a whole number.
It would not be a whole number, so it is prime. Okay? Now, are there going to be some exceptions? Are you going to get a number like 169 that you can't divide by those, but still can divide by something? Yeah, but you're not going to see those numbers this year. Okay? So, just make sure you're going up through 11. 2, 3, 5, 7, 11. That'll get you right. Number 21. How about the number 21? Can I divide it by 2?
No.
3?
Yes.
Yep. So this is composite. All right. Now, I would like for everybody to do numbers 7, 8, and 9. Tell me whether they are prime or composite.
7 is easy. That's what I was doing.
Prime or composite. Okay. Now, we didn't do very well this round, so make sure you pay real close attention. 7 should be easy. 3 is one of our key prime numbers, isn't it? So 3 is prime. This is prime. Number 8, 27. I cannot divide it by 2, but I can divide it by 3, so this is going to be composite. And 47. Can't divide it by 2, can't divide it by 3, not 5, not 7, not 11. This is going to be prime. I like to see everybody go again with 4, 5, and 6. Be careful, one of those is very, very tricky. 4, 5, and 6. So 51, 11, and 71. Now, let's look at these. 51. Can I divide 51 by 2? No. Can I divide 51 by 3?
Yes.
Yes. 17. 3 and 17 make 51. So 51 is composite. Yeah, you can tell. If you add them together, you get 6, so you can divide it by 3. All right. 11. Well, 11 we know. That's one of our key prime numbers. 11 is prime. And number 6, 71. Can't divide it by 2. Can't divide it by 3, or 5, or 7, or 11. 71 is prime. Now, the next thing. We have to find the prime factorization of each number. Now, I'm teaching it different this year than I've ever taught it before. Didn't you guys have Mrs. Bontrager last year? All right. I saw a bunch of people doing it this way. I'd never seen it before. And I was like, that is a really cool way to do this. So, here's what we have to do. find a prime factorization. 88 is a composite number. And so I want to break it down as small as I can, and I want to find all of the prime factors. So I'm going to put 88 down here, and I'm going to divide it.
Mr. Holsopple, did you mean Miss Buckner's math class or her class?
Math for math.
Yeah.
Okay? So I need to divide that, and I'm gonna try my prime numbers. These are the numbers that I'm going to divide it by. Now, I will tell you, there's going to be lots of different ways that we can all get to the same point. Here's what I'm going to do. I'm just going to start in the smallest one. Okay? So I'm going to start with 2. 88 divided by 2 is going to be 44. 8 divided by 2 is 4. 8 divided by 2 is 4. Next, 44. I'm going to divide that also by 2. 4 divided by 2 is 2. 4 divided by 2 is 2. Next, 22. I can divide that by 2. That's going to be a 1 and a 1. And 11 is prime. As soon as this number up here is prime, we stop. Okay? So, when I write this prime factorization out, it's going to be 2 times 2 times 2 times 11. Okay? Now, another way that we can write this, and this is a preferred way, instead of 2 times 2 times 2, I'm going to write 2 to the third times 11. Now, one more thing. When you are dividing these, only use these numbers. All right? It's going to get sideways if you use other numbers than this. Only use 2, 3, 5, 7, and 11. So, don't put a 10 out here. As easy as it may be, if you see a number that ends in 0, don't put a 10 out here. Okay? That's going to get you off track. All right. So, once you go through and you get a prime number up there, you stop. This is 2 to the third times 11. If I do 124 right here, I'm going to start with 2. 2 goes into 12 6 times. 2 goes into 4 twice. 2 goes into 6 3 times. 2 goes into 2 1 time. And 31 is a prime number. So 124 is 2 times 2 times 31, or 2 squared times 31.
There's a different way how to write that out.
I'd like everybody to do number 16. Give me the prime factorization of 100. You can start off with 5. You can start off with any of these prime numbers, okay? But don't start off with 10.
There's another way you can do it instead of the stacks.
Yep. And that's the way I taught for many
You
years.
can like go down. That's
Yeah.
what we did.
A factor tree. And that's what I did. That's what I did for a lot of years. But I think I like this way better.
I like that.
Our math teacher last year, she said that we could use like, she taught us how to do it. Does it matter what order?
No, it does. Well, it does not matter. Lyndon asked a good question. He says, "Does it matter what order?" It does not matter what order you divide by, but it does matter what order you write them down. Okay? Your smallest number should be on the left, and your largest number should be on the right. So when I do 100, I'll divide 100 by 2. That'll be 50. I'll divide 50 by 2. That's 25. I'll divide 25 by 5, and that will be 5. 5 is prime, so I can stop. And I've got 2 times 2 times 5 times 5, which is 2 squared times 5 squared. Okay, I would like everybody to do number 14. Find the prime factorization of 165. Okay. I have 165 out here. All right? Give me a number that I can divide this by. Jaylee, what's a number I can divide this by? 3. If I do that, now everybody watch how I'm doing this, okay? Because I can't write numbers down here. There's not enough room. 3 goes into 16 5 times. That's going to be 15. So 16 minus 15 is 1. I've got 1 left. I'm going to bring that over here. Bring your 1 remainder over here. Now, 3 goes into 15 5 times. So now I've got 55. Serena, give me a number that I can divide this by. 5. 5 goes into 5 once. 5 goes into 5 one more time. And 11 is prime. So I've got 3 times 5 times 11. Now, I'm going to erase all of our work. And I'm going to ask you one more question. And this is the question that you're going to see on the I-step. How many prime factors does each number have? As I look at this, I'm not going to look at the way it's written here. Okay? Don't look at that. That's going to be confusing. Look at the one with the exponents. How many prime factors does it have? It's got 2. 2 and 11. That's 2 prime factors. Same thing down here for number 13. Don't look at it written out like that. Use the one with the exponents. This also has 2 prime factors. Down here, 100 also has 2 prime factors. Number 14, 165 has 3 prime factors. All right? That's the question that will be asked of you on the I-step. Now, what's different about these? Jaylee.
They have like numbers with them and exponents.
And
Letters.
letters. What are letters called? Algebra, they're variables, okay? We've got variables with it. So, here's what we have to do. We're going to break this number down just like we did before, okay? So 20xy, I'll factor it, I'll tell you, 20xy is going to be 2 times 2 times 5, okay? That's 20, which we could get if we took the time to do it. But then I also need to put in, and everybody watch this, times x times y. All right? 18 is going to be 2 times 3 times 3 times b times c. If you have variables out here, don't use exponents with your numbers. So don't write 2 times 3 squared times b times c. Don't do that, all right? Over here, 11 is prime, so this is just going to be 11 times p times q times r. Now, watch down here. I want everybody to see this one. 36, okay? 36 is going to be 2 times 2 times 3 times 3. Is everybody okay with that? If we divided it all out, that's what we would see. Now, watch what I do with this. G squared is going to be times G times G. I need 2 G's there since it's G squared. H squared is times H times H. 44, we'll factor. 2 times 2 times 11. Everybody finish that for me. 23. 44 is 2 times 2 times 11. Give me the rest of it. Give me the factorization of that. Okay. Fantastic. 2 times 2 times 11 times m times n. Last thing that I want to show you today. I need to fill in each dot so that this becomes a true sentence. Watch how I'm going to do this. Let's find the prime factorization of 252. So, 252. I've still got my key primes, 2, 3, 5, 7, and 11. Let's see, what can I divide this by? Let's see. Amy, what's a number that I can divide this by? 2. Yep, I can divide it by 2. Alright, so 2 goes into 2 one time. 2 goes into 5 twice. There was a remainder of 1. And 2 goes into 12 6 times. Next, I'm going to divide this one. Abby, what's a number that I can divide 126 by? 2. 2 goes into 12 6 times. 2 goes into 6 3 times. So now I've got 63. Jennifer, what's a number I can divide 63 by?
7.
I can divide it by 7. If I go 7, 63 divided by 7 is 9. What's a number that I can divide 9 by? Lynn, I've heard from you. Bryce, 3. I can divide 9 by 3. I've got 3. 3 is a prime number. So here's what I have. 2 times 2 times 3 times 3 times 7. Is everybody good with that so far? Good with how we got here? Okay, now, watch. I'm gonna rewrite this, okay? I'll rewrite this over here. 2 times 2, I can rewrite that as what? Oscar, how can I rewrite 2 times 2? 2 to the second. 2 squared, alright? Now, 3 times 3 I can rewrite as 3 to the second and times 7. So is everybody good with how I got from here to here? Everybody sees that? Okay, so what do I need to put in that dot? Everybody look, everybody see it? Griffin, what do I need to put in that dot? 3 to the second. Alright? So, when you have to fill in the dot, just do the prime factorization and then fill it in. Yes?
Okay, so 252 divided by 2, how did you get 126?
Okay? Because 2 goes into 2 one time. 2 goes into 5 2 times, and that's 4, right? So there was 1 left, you have to put it over there. Then 2 goes into 12 6 times. Okay? Now, I do have a comic for you. Everybody knows what an Etch-a-Sketch is, correct?
Yes.
Etch-a-Sketch, those little toys where you twist the knobs and it draws, and then you shake it and it erases it.
Yeah.
You have one with you?
So, here we go. This is the National Museum of Etch-a-Sketch Art. Down here, somebody's got a TV camera, and the guy's giving an interview. The owner's giving an interview, and he says, well, structurally, the building is fine, but sadly, the earthquake destroyed all of our art pieces.
That's when you shake it. And you
What's going to happen in an earthquake? All the... Okay, here you go. Now, as you do your homework, a couple things. I don't care if you abbreviate P and C for prime and composite. Okay, I don't care if you do that. When you are writing the prime factorization, I want you to show your work exactly by the problem. Okay, don't put all of your answers over here and your work scattered over here. Don't do that. Put your work by your answers. Also notice, 12 through 40 are only even. 12 through 40.
12 through 40 you're at the even?
Okay, yep.
Or is that just...
So you're going to do 12, 14, 16, 18, 20, all the way up to 40. Then 48,